Welcome to Grand Canyon Part 2. I'm going to show you about what I learned at the Yavapai Geology Museum. This is how the Grand Canyon formed. It took over 1 million years, and this is how it was formed. First, a seafloor dove under the edge of North America, and it carried change of volcanic islands towards the continent. Then, it was unable to follow the plunge of the denser seafloor. When the volcanic islands collided with the edge, tremendous heat and pressure smushed them together, forming the basement rocks. Then, erosion by rain and snow reduced the mountains to a smooth plain. The erosion continued until hard rocks 4 miles below the surface lay exposed. Then, the land buckled into ridges and basins as superconus rodinia pushed together and pulled apart. The supergroup rocks began as limey mud, sand, and lava flows that accumulated in the basins. Then, stretching and fracturing broke apart the superconic rodinia. Supergroup rocks tilted in these miles-long blocks across these fractures. Then, supergroup rock ridges eroded quickly, leaving only scattered remnants. Broad swaths of basement rocks were exposed once more along the margins of a new basin. Then, the first advance of the sea buried the remaining ridges of the rocks under beach sand and limey mud. Then, at the end of the Paleozoic, the enormous volume of sediment spotted in seas, deserts, and swamps of the coastal Arizona region had become a vast sheets of rock 4,000 feet thick. Then, rock layers visible in Grand Canyon today were once buried under thousands of feet of debris as mountains to the south and west shed eroded sediments across the northern Arizona region. The nearly level uplift of the Colorado Plateau is geologically exceptional. The plateau rose thousands of feet with almost no violent breaks. Now it's starting to look familiar to you. As the land rose, the erosion removed the higher, younger rock first, sculpting the landscape into forms similar to today's. That by 5 million years ago, the Colorado River established its monocourse, flowing from the Gulf of California to actively eroding Gand Canyon. Over the last few million years, active volcanoes poured lava into Western Canyon, ponding the Colorado River briefly. The rain quickly scoured the lava dams away. Now today, the results of 1,840 million years of Earth's history lie exposed before us, but geologic forces are still actively sculpting this landscape. And the layers of Grand Canyon start with some basement rock. Above it is Bass limestone. Above it is Hakatari shale. Above it is Sonoma quartzite. To the right of it, you have Tapete sandstone. Then we have Bright Angel shale. Then we have Boron limestone. In these two parts, we have Temple Butte formation. Then is Red Wall limestone. Then we have Surprise Canyon formation. Sorry guys, there's just a lot of talking in here. I'm in a geology museum, so just listen to me closely, okay? Then is the Manacacha formation. Then it's the Wesco Game formation. Then there is Glande sandstone. Then there's Hermit formation. Then up there is Coconine sandstone. Then there's Toro Weep formation. Then is the Kayabab formation. Also, frozen snow melted into river, which causes the things to melt and then cut rocks in half. And then after that, over millions of years, this canyon finally is now what it is today. The power of a river, like liquid sandpaper, uses the sediments it carries to carve its canyons. Driven by weather and climate, the Colorado deepens its course. The river gathers rain and snowmelt from the Rocky Mountains. Swollen by spring runoff and summer storms, the Colorado's muddy waters churn. Silt, sand, and cobbles grind against each other and against bedrock channels. Its water carries the abrasive load downstream, ultimately surrendering it to the Gulf of California. And empowered by time, over 5 million years work, the river does what gravity demands. And then And then after that, we stop. And then after that, we are seeing all of the seas. We have basement rock. We have now. This is actually when I was talking about over there about the layers, those were just normal. This is actual. So at the bottom we have Els, Chasm, Nis, and then we have Brahma schist, then Rama schist, then Vishnu schist, then granites, then Bath limestone, then Hecatite, Seo, then Chinuma quartzite, then the Docks formation, then we have Cardenas basalt, then after that we have the Nanko Weep formation, that's 900 million years old. Then we have the Galaros formation, the Quagant formation, the 60-mile formation. It's greater, it's less than 740 million years old. Then we have Tapete sandstone, that's in the Tonto group. Then we have Bright Angel shale, then we'll have limestone. Then we have Temple Butte formation, then Redwall limestone, then the Surprise Canyon formation. In the Supai group, we have the Watahomegi formation, the Manakacha formation, the Wesco Game formation, and the Esplande sandstone. These are 315 to 285 million years old. Then we have the Hermit formation, then the Coco Reno sandstone, then the Toro Weep formation, then we have the Kaibab formation. Gand Canyon story began in 1,840 million years ago as a volcanic island chains with the young growing North American continent. These collisions were via and crumbling rock layers into mountain and changing their minerals. And by 5 million, and a plateau rises when the supercontinent Pangaea was breaking up 245 millions of years ago. During the age of dinosaurs, North America headed northwest, colliding with volcanic island chains and adding them to its western coast. I'm speaking faster because I have to leave in some time. These collisions caused mountain building, and before the dinosaurs became extinct, the Rocky Mountains were already rising. The Colorado Plateau, future home of the Grand Canyon, also rose. Unlike the crumbled mountains around it, the plateau was elevated with only minor distortion. These uniquely level upset the stage for spectacular erosion on the Colorado Plateau. We are done with part 2. And our next video will be about part 3 of the Grand Canyon. See you later.